Analysis of multiple choice questions style exam quality by calculating the item discrimination in SPSS and Excel on data extracted from student test results using Kelleys method. Item discrimination, abbreviated ID, is a method proposed by Kelley in 1939. It is a measure of whether an item, which is a question in this case, distinguishes between students who learned the subject content well and students who did not. The measure is based on the comparison of performance between excellent and poor students in the exam as a whole. The item discrimination is calculated by arranging the student total score from the test in a descending order. Group the students based on their scores into upper group and lower group. The upper group contains the top 27% of overall scores, and the lower group includes the lowest 27% of overall scores. Count the number of the correct items in the upper group, and then count the number of the correct items in the lower group. Then subtract the correct questions in the bottom group from the correct questions in the top group. Then use the Kelleys formula to calculate the item discrimination as given here. The ID equal to upper group minus lower group divided by 27% of total students, i.e. calculating the upper group proportion and the lower group proportion and subtracting them to get the ID. An ID percentage also can be calculated by multiplying the ID product with 100. Now, the item discrimination values range from -1 to +1 based on the equation of Kelleys. The outcome of the calculation have a range of -1 to +1. Positive value of +1 indicates that the item is discriminating between high performer and low performers, and +1 indicates a perfectly discriminating item. Zero value means that the item is not discriminating between high performers and low performers. On the other hand, negative value of -1 means that the item discriminates perfectly, except that low performing students answering item correctly and high performing students answering it wrongly. As shown here in the table, the range for the ID value is listed, and the items are classified as either bad item when the ID value is from 0 to 0.24, that is based on Kelleys formula. Good item when the value is between 0.25 to 0.39. Excellent item when the value is between 0.4 and 1. If the ID value is minus, then the item is very bad and it is recommended to remove and exclude the item from the exam or the test. Item discrimination analysis based on Kelleys equation to evaluate multiple choice exam questions in SPSS and Excel using the formula item discrimination equal to upper group minus lower group divided by 27% of total students. Item discrimination analysis in SPSS based on Kelleys equation. The analysis will evaluate and identify multiple choice exam questions that are good or bad in discriminating between high performing students and low performing students. So this analysis is only designed for multiple choice questions, and the analysis is based on an equation generated by Kelleys to determine the item discrimination or the question discrimination. And the way to do that is to calculate the total scores for each individual participant achieved in an exam, and then group the student into an upper group and a lower group. The upper group contains top 27% of the total score, and the lower group includes lowest 27% of student total scores. And then proportion can be calculated for the upper and the lower, and a percentage can be generated for each individual item or question. And the value for the item discrimination can be from -1 to +1. Here in this SPSS data view, I have a result from exam and the test for 20 students participated in this exam that included in it 20 questions, 20 multiple choice questions from 1 to 20. And each individual student answered the multiple choice questions, and their answers are recorded as either 0 or 1, given a value of 0 or 1. 0 represents wrong answer, 1 represents correct answer. And from those 20 questions, we aim to determine which one of these questions are good questions and which are bad questions, in distinguishing between excellent students and low performing students. And to do the item discrimination analysis, it is a multi-step. The first step is to calculate the overall mark or the total mark achieved by each individual student, i.e. to add up all the correct answer recorded by each individual student, add them up and generate a new variable, call it total score. And to do that, we click on transform, compute variable. In this new window, I'm going to generate a target variable, call it total score. And in the total scores, I'm going to add all the values within each individual cell together. So i.e. add all these multiple variables for each individual student together to generate the total or overall mark. So we need to use the sum function in this case. And the sum function, to get the sum function, click on all, scroll down to statistical, and then click on sum, drag the sum command into the numeric expression. A numeric expression, the sum is followed by a bracket, so we need to enter or transfer each one of these questions or variables into the bracket or between the bracket and separating each question by a comma. So if you click on the first one and then add a comma, click on the second one, transfer, comma, and then third one, and so on. And since we have here 20 exam questions, I had already generated these questions labels in Word document, type them, and I'm going just to select them and copy them and then insert them or place them in between the brackets. So if I delete that, add the bracket again and Control V or paste. So all the 20 variables have been placed in between the brackets separated by a comma, and this will instruct the software to add all the values for each individual student, to add them up together and generate a new variable called total score. If we click on OK, again we'll see here that a new variable is generated called total score that has in it the overall mark achieved by each individual student. And I'm going just to edit the column a little bit by removing the decimal point and making it 0, making it at the center, and then since it is a marks and this is a scale, it's measured at a scale. And then I'm going to reduce this, keep this up to 66, so to reduce the column. So now to continue with the item discrimination analysis, we need to rank those overall mark or scores in a descending order from high to low. So we're going to click on data, sort cases, and we are going to sort the cases by the total score and in a descending order from high to low. Again, as we can see here, the data are rearranged that we have the highest score achieved by student are 17 out of 20 and the lowest is 8 out of 20. The next step in SPSS is to rearrange the data to be able to manage to calculate the upper group and the lower group. So we are going to use a function called transpose, in which we transpose these questions from being in a column into a row and swap the students' numbers and IDs, swap them from rows into columns. So it is a reciprocal swapping. So if we click on data, scroll to transpose, and then we are going to transpose all the variables with even the total score into the box of variable, and we're going to name the variable, move the student ID into name variable, and if we click on OK, a new window appears showing that the questions has been transposed into rows and student IDs had been transposed into columns. Again, as this is for question number 1, 3, 9, 19, and 2, similar to the original 1, 3, 9, 19. It's just only it has been transposed. I'm going to do a little bit of editing here as the width of the column is large, so I'm going to reduce it a little bit to do a little bit of editing. So I'm going to change first of all the decimal into 0 for the copy for all the data we have here for the value of the value or the scores within each cell. And going also to change the column width as it's too high for 12, so we'll keep it at 6, give it a 6, and this is also 6, and see if I can copy it, and if I can drag it and change it for all, if I click Control V, again it has changed the column to 6, number 6, and again align them into the center, so keeping the data within the center of the cells. And for measurement we're going to change that into scale, for all the data. So when we look at the data view, it is much neater and much better. We could reduce it more, but that's more than sufficient. Again, if we look at the total score, the order and the rank is kept also constant, hasn't been changed since we have done the ranking. So now we have first of all calculated the total score, ranked the data, and then transpose the data. The next step is to group these students into upper group and lower group and calculate the proportion in each. And for the upper group, it should contain top 27% of the student total scores, and the lower group lowest 27% of the total score. And since we have here 20 students, and if you use a calculator, though we don't need a calculator, it's just only we have here 20 students, and we need to generate a group that has 25%. So we will multiply that by 27%. That will generate 5.4. So we will convert that to integer. So we will put in the upper group 6 scores, overall scores from 6 students, and in the lower one overall scores from 6 students, again in the low performing student. So in this case, so we're going to generate upper group that includes 6 overall grade from 6 students, and the lower one overall grade from another 6 students that are performing poorly. And the way to do that is to generate again here a variable, call it upper group, lower group. So compute variable, generate a target variable, call it upper group, and the upper group, again we can see here the order is and the rank is kept in place. So K1, as we can see here, is the highest mark or the highest total score here. The first 6 has the highest total score, so we're going to select 6 from K1, 1, 2, 3, 4, 5, 6 up to K4 here. So what we will do here is to click on brackets here, move the first value from the variable K1, and then add a plus sign, then add the second one, and then another plus sign, a third one, a fourth one, a fifth one, a sixth one. So we have here top grade or top overall score from the top performing student. So this is the upper group, and we're going, since we have selected 6 students, divide that by 6. And if we click on OK, a variable generated here for the upper group for all the 20 students and the 20 questions. Now, to generate the lower group, we're going to do the same thing, but we're going to select the lowest 6 scores. So here are the lowest 6 from 1, 2, 3, 4, 5, 6. So starting with 7, moving 7, adding plus sign, and then this variable, plus sign, this variable, and then the next one. We haven't moved 11th, and then we move the other one, and then the next one, and finally the last one. So we have here 1, 2, 3, 4, 5, 6 variables moved into between the bracket, and we need to add them up and then divide them by 6 to calculate, to generate the lower group. So here we are calculating the lower group, and if you click on OK, and again another variable is generated called lower group. The next step in generating and calculating the item discriminating IT is to subtract the value from the lower group from the upper group. And again, to do that, we click on compute variable, and I'm going to reset that and call it ID. And instead of retyping the whole thing, you just click on upper group, put the minus sign in between, and then lower group, and then click on OK, and ID, or this item discrimination, is generated here. We're going to ignore the value for the total score from our calculation, but what is genuine here is that this is the ID score, and the ID value should be between -1 to +1. So we could see 0 value here, and as we can see here, a 0 value, and a 0 value here, and a minus value here, and a positive value of 0.5. So if we take the first example here or the second one, -0.17. -0.17 indicate that there is something not correct with the question. The question is, in this question number, let's say, which question is this? Question number 2. Low performing students are answering the questions correctly, and high performing students are answering it wrongly. So this question has to be removed from the exam, as it is not discriminative. It does not distinguish between high performing and low performing. Now, the other thing is that also the question number 3 has a value of ID value of a 0, and that is indicate that this question is not discriminating between high performing or low performing, as they both scored the same on this analysis, ID analysis. Again, the same thing for question number 4. If we scroll down here, again, this is a question number 16, and if we show from question number 16, it has a positive value and it is 0.83. This is a very high value, which indicates that this is a very good question, that it can discriminate between excellent students and poorly performing students. So anything, the rule for ID analysis, the rule for it, that anything above 0.25 up to 0.39 is considered to be a good question. Anything above 40%, 0.4 and above is considered to be a extremely good question. So this question is extremely good. This question, again, this question, though it is positive, but the score or the value for it is 0.17, which is less than the standard. The standard for classifying questions has to be above 0.25 and above to 0.39, but in this case it is below 0.25. Thus, this question is a poor question in discriminating between high performing and low performing. So this question is poor questions. This question is a poor one. This one is a good one, very good one, very good one. This is good. This is bad one. This is good, very good, very good, good, and so on. So this is the way to do item discrimination analysis in SPSS for a multiple choice questions, and it is of a great benefit and use for those who designing an exam or an assessment for students and want to evaluate the power of discrimination of the questions and ability of the questions or the item to discriminate between high performing and low performing students. The way to do that is, one of the way to do that is to do an item discrimination analysis based on the formula formulated by Kelleys or Kelleys equation. So the way to do that is to rank your data into according to the overall scores from high to low, and then in SPSS rank them, first calculate the total, then rank them, then transpose your data, and then calculate the upper group proportion, lower group proportion, and then subtract them from each other to generate the ID. We could also, in addition to calculating the ID in this way, we can also generate an ID percentage. The way to do that is to go to compute again, and we are going to call it percentage. And to do the percentage is to select the ID, drag it here, and then multiply that by 100 to get a percentage for the item. Again, as we can see here, this item is 83% discriminative. So this is the way to do item discrimination analysis in SPSS using Kelley equation. Using Kelleys equation in item discrimination analysis to evaluate multiple choice exam questions in Excel, to identify questions that are good in discriminating high performing students from low performing students, and to classify the questions as either a good question or a bad question, following the equation of item discrimination equal to upper group minus lower group divided by 27% of the total student, and we're going to perform the analysis in Excel. Here I have a data from an Excel sheet from exam results for 20 students answering 20 multiple choice questions from question number 1 to question number 20, and the score for each question is recorded as either 0 or 1. 0 is the wrong answer, 1 is the correct answer. So here we have a categorical data, dichotomous data, two possible categories, 0 or 1, and we want to determine the item discrimination for the 20 questions to determine which question of these are good and which are bad based on the analysis. And the first step to do the item discrimination following the equation proposed by Kelleys is to calculate the total score or the overall mark achieved by each individual student. So we are going to generate here a column and we call it overall mark. And to calculate the overall mark for each individual participant, we need to add the score from all the questions from Q1 to Q20 all together. And the way to do that, click on the cell here, insert equal sign, then type sum, select the sum formula, and in the sum formula drag the range of the data to calculate the sum from Q1 to Q20. A value is calculated, 17. The grade or the mark, the overall mark for the first student is 17. And to calculate the rest, we just need to drag and hold and drag the value to the last student. So to auto calculate and auto fill the value for the overall mark for each individual student. So we've calculated the overall mark. The next step in item discrimination is to arrange or rank those overall mark from high to low, from descending in a descending order. And the way to do that is to click on the data itself, select the whole data, and then click on sort filter and use custom sort. In the custom sort, make sure that this my data has headers is ticked, and we're going to use the column which is labeled overall mark, as this is our reference for doing the item discrimination analysis and a reference for ranking the data from high to low. And we're going to rank the data in the order of the largest to the smallest. If we click on OK, again we can see here that the software has arranged the data from the highest to the lowest. So the lowest score by students was 8 out of 20, and the highest is 17 out of 20. Now, following the arrangement of the overall scores in descending order, we need to generate the upper group and the lower group. So we're going to type here upper group, lower group, then ID for ID discrimination, and then ID percentage. And to calculate the upper group proportion and the lower group proportion, we're going to use the ranked value on the overall mark. And for the upper group proportion, we need to select the top 27% of the total student who achieved total marks, and for the lower group, select the lowest 27% of the total score, so student who scored lowest. So we have to generate two groups, and the number of the student to select will be equal to, if we have 20 questions or 20 students, and we want to arrange them into upper and lower group, and we want from the upper group to include 27%, then we multiply that by 27 to get a value of 5.6, which will be approximated to 6. So each group, upper and lower, each one of them will have 6 students in it. The scores for the 6 students for the upper and the lower group. And to calculate the upper group values, and I'm going here just to highlight this, divide these groups, this data into upper and lower. So if I select the first top 6 students and label them, give them a label of green, as this is the upper one, and the lowest group 6, select from it as low as 6 students. I'm going to keep it red. Now what we want to do here for the upper value, we need to insert the equal sign and then type sum and select the sum formula. In the sum formula, we are going to select the first 6 values here in for Q1, close the bracket, and then open another bracket and put the sum formula in a bracket, and then divide that by 6 since we have 6 students. So this is the way to calculate upper group proportion. If you click on enter, the value is generated. And we're going to do the same for the lower group. In the lower group, we're going to insert the equal sign and then type sum. And then we are going to select for question number 1 the 6 values, the lowest 6 values here, close the bracket, again doing the same thing, put the sum formula with the value in bracket, divide that by 6 as the lower group has 6 students in it, press enter, a value has been generated. Now to auto fill and auto calculate the value for the rest of the group of the questions from Q2 to Q20, we're going to select, select the first row, drag it to calculate and autofill the value for the upper group, and do the same thing for the lower group, select and auto and drag to the last question number 20, and a value is generated for the upper and lower group. So here we have now upper group and lower group, and the next step to determine the item discrimination is to subtract this upper group from the lower group from the upper group. And the way to do that is click on insert, click on the cell, insert equal, select the first value here from the upper, then select, then put the minus sign, and then select the lower group, and then click enter. A value is generated for ID there. So this is the item discrimination for question number 1. Again, drag and select and drag to autofill and auto calculate for the rest of the questions. So here we have the value for item discrimination for the 20 questions. I'm going to decrease the decimals to make it a little bit by clicking on cell format and then number decimal. We're going to make it, change it, or make it, keep it 3, or even I'm going to change it to 2 to make it much easier to compare. Item discrimination value range from -1 to +1. A very good question. Good question has a value 0.4 or greater. a good question has a value of 0.25 to 0.39, and the bad question had a value of, or a value less than 0.25. And also ID value can be 0, or even it can be from 0 to -1. So those are all the possible range of value from -1 to +1. In the first cell here for question number 1 for the ID value is 0.33. This is a good question, as it can discriminate between high-performing student and low-performing student. The second question has a ID value of 0. 0 means that the question is not discriminating between high-performing and low-performing, so this is considered to be a bad question. So 0 indicate the question is bad, and 0 indicate the question is bad, and question number 4 also, so question 2, 3, 4 are bad questions, and they ought to be removed or excluded from the exam, or rewritten in another way that the ID for it will be higher. For this question number 5, the ID is 0.5, which is really a very good value, and this question is very good as it is greater than 0.4, and this question is very good in discriminating between excellent student and poor performing student. In this also ID value for question number 6, the value is -0.17. This question is discriminating between high performing and low performing, but the low performing students are scoring the questions correctly, and the high performing students are scoring the question wrongly. So this question ought to be removed from the exam, as it is not discriminating, and omitting it from the exam is the best way to get rid of it. Others value here, we can see here there is a question which is number 16, has a value of 0.83. This is a very good question, in fact an excellent question in discriminating between high and low students. Question number 19 and 20 and question number 13 has an ID value of 0.17, which is below the range here. Anything less than 0.25 is considered to be a bad question. So this one and this one and this one is a bad question, ought to be removed from the exam, and this one -1 is also ought to be removed from the exam. These 0 value for the ID are bad questions, that they do not have the power to discriminate between high and low performing student. So this is the advantage of using item discrimination analysis based on the Kelleys formula, as it will permit identifying and evaluating questions and determining which questions are good, which are very good, which are bad, to remove from the test. Here, as we can see, out of the 20, 1, 2, 3, 4, 5, 6, 7 questions out of the 20 questions for the multiple choice for this exam are a very bad questions that has to be removed from the future exams. So this is the way to do an item discrimination analysis in Excel. First you have to calculate the overall score, arrange the overall scores in ranks from high to low, and then group the student into upper and lower group and calculate the proportion in each group, and then determine the ID value for each question. We could also do a ID percentage by inserting in this here equal sign and then selecting this and selecting the ID value, multiplying it by 100 to generate the percentage of the ID, and we autofill and auto calculate for the rest of the questions, and also we can reduce the decimal point here to something manageable and easy to recognize. So this is the benefit and the advantage of using ID for assessing multiple choice exam questions.